Okay, so today, guys, we're going to take notes over, it's pronounced DeMoivres Theorem, I think. It's close enough. Okay, the V is kind of silent, so it's DeMoivres. But anyways, it's going to be easy because yesterday we started it already. So the bottom two problems that were kind of long and drawn out yesterday, I know, right? The bottom two, those are like what we're going to do today, right? But once you've seen a few, they're easier. So if we look at the top of the notes, it's actually the formula of why I told you needed to start with CIS every time, okay? You have to start with CIS because if you're trying to turn something into rectangular form, in other words, if I want z to the fourth power, okay, then this is the theorem that will do that for you. Rather than writing it out 4 times or 10 times or 7 times and foiling it, then what you can do is whatever exponent this is, let's say it was 5, then you take r to the 5th power and you take 5 times your theta. Okay, so you have to get it in CIS form first. And once you apply it, you can turn it back into rectangular form. Okay, CIS is polar, right? So this is considered polar form because as the formula calls for r to the nth power, well, this is r, and it calls for n, which is the exponent, times theta, and this is theta. So the difference between, on your notes, if you look carefully at numbers 1 and 2, 1 and 2 are already in what form? CIS. So like half the work is finished. Versus look at number 3 and 4. If I want z to the 8th power, if I want this to the 8th power, it's already in rectangular coordinates. This is x and this is y. So to do numbers 3 and 4, you have to put them in CIS form first. Okay, so it's kind of like you go to CIS and you go back. Okay, but this down here is much easier problems. Right, so if it's written like this, let's follow the formula. If I want to raise it to the 4th power, it says r to the nth power. So I want 4 to the 4th power. Okay, then CIS. And pi over 12 is not on our unit circle as a degree. Do what? Well, if you have 30 degrees is actually what? Pi over 6, right? Right. 2 pi over 12, not pi over 12. So it wouldn't work. So then we're going to leave it as 4. Remember the 4, if you look up here in this formula, you have to take whatever the exponent is and multiply it by theta. So I'm going to take 4, because that's the exponent, 4 over 1, and multiply it by theta, which is pi over 12. So in your calculator, do me a favor. Find 4 to the 4th power. 4 to the 4th power. You should get 256. So there's your 256. CIS, right? That means cosine and sine. And then on here, to simplify this, the 4 becomes a 1 and the 12 becomes a 3. And then you can just multiply straight across. You get pi over 3. Now, guys, is pi over 3 on the unit circle? Yes. Okay. So what this means then, okay, is this means you want 256 times, because now I've got it in the form I need, and I'm trying to get it to rectangular form. I'm in CIS, my goal is to get it to rectangular. So that means I need to find x and y. So this means it's 256 times cosine at pi over 3 plus 256 times sine at pi over 3. And what goes on the end, guys? What letter? The I. Now, if it wasn't on the unit circle, you wouldn't even need to write this line out. You could type it in your calculator. 256 times cosine of whatever, write the number down. 256 times sine of whatever, write the number down with an I. You wouldn't even need to write this out. But these are actually on, pi over 3 is on your unit circle. So what's cosine at pi over 3? Yeah, it's 1/2. So 256 times 1/2 is 128. Plus Now you're going to take 256 and multiply times sine at pi over 3. And sine at pi over 3, I'm going to put 256 over 1 times root 3 over 2. And forget about your I. Does this fraction right here reduce at all? Because you can't do it by hand. I'm sorry, you can't do it with the calculator because it has a radical. So you can do it by hand. This becomes a 1, and this becomes a 128. I just reduced it. So on the top, I have 128 times root 3. So plus 128 times root 3. And don't forget about what on the end? The I. Okay, so now you're in rectangular form. This is X, this is Y, which was the goal. Okay, so I want to reiterate something to you, okay? If you are trying to get it in rectangular form, like this problem, and you're, in other words, you're raising to a power and you want it in rectangular form. If you're already in CIS, it's easy. Just apply it. You do 4 to the 4th power and you bring the 4 in front. You perform the CIS and turn it back into rectangular. Okay? So let's look at number 2. On number 2, once again, I'm in rectangular form already. I'm sorry, I'm in CIS form already, so that's the easy one. I'm saying Z equals 3 CIS 120, and what power do I want? I only want to do what to it? Right, I'm going to square it. Okay? So if you look back at your formula, that means you want 3 squared CIS, and then the 2 goes in front of the theta. So 3 squared would give you 9 CIS, and 2 times 120 is 240. Okay. You now have it simplified out, no exponents, it's nice and pretty in CIS form. You want to turn it into X, Y, or in other words, rectangular. So just apply it. That means you want 9 cosine of 240 plus 9 sine of 240i. Is 240 on the unit circle? Yes or no? Okay, so if it's on the unit circle, I would write it out. If it's not on the unit circle, I would just do it in my calculator. So to write it out, we want 9 cosine at 240 plus 9 times sine at 240 I. What's cosine at 240?
-1/2.
Okay, so then I now have 9 times -1/2. I'm going to go ahead and put the 9 over 1. So you end up with -9 over 2. Now, sine at 240 would be 9 times, and you're going to use the unit circle. What is sine at 240? Yep, -√3 over 2. Don't forget about that I. Don't drop the I. You're in rectangular form, you're going to need it. Okay, nothing cancels or simplifies. So you should end up with plus a -9√3 over 2. And don't forget about your I. If you write this, guys, it's just a minus instead of plus or minus. It's the same thing. Okay, now, let's look at number 3. Number 3 says Z is 3 minus 4i, and I want Z to the 8th. Okay, that means I want to find this to the 8th power. Okay, if you want to find it to the 8th power, you have to put it in CIS form first in order to apply the formula. Right, I'm not there. So this one's the one, these are the ones that are a little harder. They're not harder, they just take more time. So you gotta put it in CIS form first. Okay, so this is X, and this is Y. In other words, X is 3, and Y is -4. Draw yourself a grid of where it would be. Put your -4s in quadrant 4. So So to put it in RCS form, you gotta find R first. R is the square root of 3 squared plus negative 4 squared. So you want 9 plus 16, which is gonna give us the square root of 25, so R is 5. So we're halfway there. Now let's find tangent. Tangent of theta equals y over x, so negative 4 over 3. Is that on my unit circle anywhere? No, it's not, is it? So in your calculator, you're gonna need to type for me the inverse tangent of negative 4/3 and find the answer. So what's theta, guys? Negative 53.13. Be sure your calculator's in degrees. So negative 53.13. Okay, look at our picture. We have to decide, number 1, are we in the right quadrant? And number 2, are we gonna add 180 or 360? Okay, well, I'm supposed to be here. I'm at negative 53, so there's 0 and negative 90. I am here. So to get all the way back around, how much are you gonna need to add? 360. So put yourself a little note, we're gonna add 360. So theta would be negative 53 plus 360, which is 306.87 degrees. .87 degrees is theta. Okay, so our CIS form would be 5 CIS 306.87 degrees. What power do we need to write it to? Okay, look into the 8th power, and now then just apply the formula like we did before. This one's actually even easier because it's not in your unit circle, you can use your calculator. So I want 5 to the 8th power CIS, and then 8 times your angle. It's gonna give us kind of big numbers. You will get messy numbers on here a lot of times, especially if they're not in your calculator. I'm sorry, especially when they're not on your unit circle. So 5 to the 8th power is 390,625 CIS, and 8 times 306 is 2,454. Okay, this is what I'm trying to explain to you now. Now, you can either write it out really long, in other words, 390,000 cosine 2,454, plus 390,000 sine 2,454 I. You can write it all out. Or you can just type it in your calculator one at a time. That's what I would do, rather than having to write that huge long line out. Okay, when they're not in your unit circle, I recommend just typing it in your calculator. Okay, so right now type in 390,625 cosine at 2,400. Yeah, it's a big number, but type it in to make sure you're getting it right. And the number is huge. I think you get 1,648,000. No, it's 164,000. Sorry, I got one. So 164,000. I'm gonna say minus, because now you're gonna do 390 sine of that number, and you end up with a minus. And don't forget about your I on the end. I'll give you a second to catch up.
What's the second?
354,141. It came from 390 sine. Hey, if you're still confused about where I'm getting this answer, okay, okay? I did 390,000 cosine times this number, and that gave me this 164,000. Then I did 390,000 sine of this number, and that gave me the 354. That's where I got the numbers from. Does that make sense? Okay, I just want to write out that huge long line. All right, now number 4. It's asking me to find this to the 10th power. So step 1 is check and see if it's in CIS form. Is it? No. So let's get it that way. What does x equal in this problem? X is gone. There's nothing there. It's 0. Y is a number in front of I. So what's y here? 5. Now then you're going to graph the point. 0, 5. It falls right here. The ones with 0 in it are kind of nice because we don't even have to find theta. What's theta in this problem already? We know it. 90. Okay? So what we still need to find r. So if you're going to find r equals the square root of 0 squared plus 5 squared. So the square root of 25. Some kids, for some reason, on the last quiz, you guys left it as the square root of 25. Or when you took the square root, you left it as the square root of 5. That's not right. The square root of 25 is just plain old 5. So r is 5. Okay, we already know theta because of the picture. So theta is 90 degrees. So then you've got 5 CIS 90 degrees. Now number 3, they were not on the unit circle, so I didn't make you stretch it all the way out. But no, 90 degrees is on the unit circle, so it's better to write the whole thing out. So we're going to write 5 cosine at 90 degrees plus 5 sine at 90 degrees, and then your I. Oh, I'm sorry, guys. I made a mistake here. What did I forget to do? Yeah. Not square it, but once you get into CIS form, I didn't do what it told me to do. What do I need to do? Right, put it to the 10th power. That would have just turned it right back into what we had. Okay, I forgot to take it to the 10th power. I'm sorry. So take it to the 10th power, which means you're going to have 5 to the 10th. If you follow the formula. CIS, and then the 10 drops in front of the angle. Five to the 10th power is huge. That's the million. It's 9 million. And 10 times 90 is 900. Okay, now we can do cosine sine. Is 900 on the unit circle? No. So what you're going to do is listen to me really quick. You're going to do this 9 million, type in the whole thing, 9 million cosine of 900, hit enter, and write the number down. I'm going to give you a second because I want you to try it. I want you to take 9 million cosine of this 900 and write the number down. That's x. Did you get just the negative of that same number? Yeah, it's kind of weird. You get negative 9 million, sorry. Then you're going to put your plus in here. What's going to happen now? Then type in 9 million sine of that number. If you do it right, you get 0 or 0i, right? So you don't even need it, so the answer is this number. Okay, now turn it over to the back. And we'll do some practice.